So what did the number 0 say to the number 8? Oh, don't worry. I'll get to the answer to that. But while we're here, let's go ahead and talk about the slope of the line. Finding the slope of a line. Let's find the slope of the line. Okay, so the slope, or the steepness of a line, is how we talk about a relationship between two variables. And it shows up as a ratio, which really looks like a fraction, but the ratio is rise to run. So we can say that our slope is a ratio of rise to run. When we talk about rise to run, we're talking about how it changes vertically to how it changes horizontally. When we're looking at a line or data points, we can see how does it change vertically over how it changes horizontally. And that's our slope, much like a step with stairs. How much does it slope? The rise to run, the rise to run. The slope is how much you have to lift up your foot to how far you have to go forward to get to the next step, the rise to run. So let's practice that out a little bit in like this particular situation. Okay, so I have 2 data points. Let's look at this. So we have, and here's a coordinate. This is a coordinate 2, 2, and then we have another coordinate 5, 4. So as you can see, 2, 2, we have 1 point, and a point at 5, 4 is my other point. So let's look at these things. So remember, the slope is the ratio of rise to run. And let's see how much it rises. So from 1 point, it rises 2, and then it runs 3. It rises 2, and runs 3. So we would say the ratio is 2 over 3. And so we'd say our slope is 2 to 3. Now the reason why I have over here written positive slope is because it is positive. We read graphs from left to right, and as you go from left to right, we see that our line is increasing in value, which we call a positive slope. But also you can see it as a positive slope in the case that your rise is going up, and then it runs forward. You can see it differently on this one. Like on this situation, we do have the coordinates. Coordinates is 1, 4. And we have a coordinate 4, 2, as we see here and here. So coordinate 1, 4, and coordinate 4, 2. And let's look at these. So we can see the rise for the steps, but it goes down 2. So really that's negative 2. And then it runs 1, 2, 3. So you could say this ratio is negative 2 rise, and it runs 3. And we call that a negative slope. You can see it on a graph because as you go from left to right, the values go down. And that tells us, okay, this slope is going down. But we also can see it in the numbers themselves. It goes, the value from 1 point to the next, when it rises, it's actually rising down. So let's play around with that a little bit more. Okay, here's another table of information. We don't have a graph, but let's take a look at it. Now remember, we're looking for the rise to run. Now rise, remember rise is going to be up and down. So that's, I'm going to be looking at the y values, and the run is going to be the left to right, which is my x value on a graph. So let's talk about the rise. So it's rising. Let's look at the y's. Okay, so I can grab any point, any coordinate. So I'm going to grab this one, and I can go ahead and grab the next one right after it. And I can see, well, how much does it rise? It rises 3. So right now I can say that for my rise to run, it rises 3. Now let's look at the run for the same spot. From negative 1 to 0, it's rising 1. So I can say it's 3 over 1. Now this seems like my slope. It quite possibly is, but I'm going to check another place. I'm going to check my rise. I'm going to go from the 6 to the 15. And I'm going to jump this big. So how much does it jump to go from 6 to 15? We can see that it jumps from 6 to 15 by plus 9. So we can say, well, it's rising 9. And then let's talk about the run. I gotta use the same coordinates. So from 1 to 4, it changes 3. Okay, notice that it's 1, and then 1 to 2, 3 to 4. So it rises 3, or it runs 3, so I'm gonna put a 3. And 9/3 reduces down to 3 over 1. So we could say the slope of this situation, of this line, is 3. Because 3 over 1 equals 3. And notice it is positive in value. So you can find it from a table. In fact, we can grab any points. We can go from 0 all the way to 15. So it is running 15. And look at it right here from -1 to 4. Well, hold on. Nope, we can't do it. That was so not true. This is something you got to keep an eye on. So even though we do our x over y, when we do rise over run, we do y over x. And I almost did a scoopity-doopita, which would not have helped us. So let's look at that again. So it's rising 15, there it is. And it's running from -1 to 4, which is going to be, looks like 5. And 5/15 reduces down to 3. Again, positive. So you can grab any 2 points. It really doesn't matter. So let's look at some situations here. Let's play around here. We can look at a graph. So we can grab any point. So we can take this point, and we can take this point right here. And let's see how it's doing. So let's see how much it rises. In this case, it's going down, so I can go there, 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 there. And I got to check the interval. It looks like it's going by 1. So 1, 2, 3, 4, 5, 6. So it dropped -6, and then it ran 1, 2. But again, I have to check the interval, and it did go by 1, so 2. So it rises. Remember, slope is y over x. I'm doing that to remind myself too. So -6 over 2, which equals -3. Let me try this guy. This graph right here, I'm going to grab this point right here. I'm going to grab this point here. So it rises, and it does. 1, 2, 3, 4, 5, 6. And then it runs 1, 2. So it's a rise over run. So rises 6 and runs 2, which is again 3. And this one's going to be positive. And as I read the graph from left to right, graph 2 is going up in value. Graph 1, as I go from left to right, is going down in value. So it will be a negative slope. A couple things you want to keep in mind is I could use any points. I could use this point. I'm really going to use points that meet at intersections of the graph because I know where their value is. So make sure you look for that. Like for instance, I'm not going to use that point right there because I don't know its value. I'm not going to use that one because that value is hard to find. I could use this one though, and that would work. So let's see, how much does it rise? It goes 1, 2, 3, and it runs 1. So it rises 3 over 1, which equals -3. Got to remember that. It's like a negative. It's a dropping. So we're going to put the same spot. Okay, that's the graphs. All right, let's talk about the tables. I'm going to speed this up a little bit. For table 1, actually, why don't you pause it and try it, and then I will do it. All right, I just grabbed 2 points, and I'm just remembering rising is going to be my y. And so I went from -10 to -1, which was 9. So that's on the top part of my ratio. And the bottom number is my run. So from -6 to 0 is 6. And so my slope is 9 over 6. My ratio, 9 over 6. But it's also my slope. And I can reduce that. So 9 over 6 can be 3 over 2. And that's my slope. It's 3 halves, or 3 over 2. Let's try table 2. Grab any 2 points you want and see if you can find the slope. Press pause and try it. All right, I tried to pick nice easy numbers. So I went from 4 to 3, which looks like it is going down 1. So my slope is going down. It's -1. And then it ran from 2 to 4, so it went up 2. So my slope is -1/2. Now let's look at an equation. This is real significant here because when you're looking for slope and the y-intercept, the slope is going to be your coefficient. It's the number that sits in front of the x. So right here, 2.5 is in front of the x. That is my coefficient. It's also my slope. So all you got to do is look for the number in front of it. This guy right here, you're going to grab the negative also. This tells us that is a negative slope. This is my slope right here. So look for the coefficient, and once you found it, you have found the slope, but pay attention to the negative. Now the y-intercept, that's where it crosses the y-axis on my line. And this one, this equation crosses at +5, and this one crosses at +20. So it really is where my line crosses, or where it starts in my story very often, but where it hits the y-axis, and then my slope. And sometimes you can end up with equations like this, where y equals x minus 2. My slope is right here. My coefficient is 1. So my slope is 1, and the y-intercept is -2. So a couple things you want to be able to work on for each of these. All right, you know what, one more time. I've got 2 points. I would like you to find the slope of that. Press pause and try it. Pause, it's the one that looks like the number 11. All right, let's take a look. So my rise to run, my rise is my y, which in graphing, we always have the points, the coordinates are x and then y, so that's my second number. So I'm trying to see how much it goes. It's at 5 and it's going to 10. So from 5 to 10, that means it increasing by 5. And then my run is going to be my x number, so that's 3 traveling to -2. That's what it's running, so let's go 3 to -2. It's a change of, you can see that it's going down in value to go from 3 to -2, and that goes 5. Well, 5 over 5 equals 1, so my slope is -1. Because of this negative right here. If they were both negative, then it would be positive because a negative divided by a negative would be positive. But in this case, we have one negative, which makes the whole thing negative. All right, well, this stuff gets easier over time as you keep practicing it. So what was my joke? What did the number 0 say to the number 8? He said, "Nice belt."